The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Hello everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont. We're with HawaiiTracker.com, giving you guys another Kilauea volcano update. Today is the 47th day of the eruption, so over a month and a half now, February 5th, 2021. And what I have lined up for you guys to start off here is a time-lapse and a thermal camera from the USGS Hawaiian Volcano Observatory. It's F1 camera for the last month or so. So that's kind of the very beginning time when a lava lake on its western portion, or eastern portion, I'm sorry, over here starts to crust over. That's like the very first thing that happens when when a video loops to the beginning. You'll see this red all the way right there. And we have the crusting over in the back part, and gradually the area of active lava by the end of the video ends up being only in here, as we currently are today. And that's the main story today, is that we've had a pressure drop on Kilauea volcano. A pattern that seems to follow in a typical deflation-inflation cycle. We haven't seen the inflation yet, but what we have seen is the reduction in pressure of lava coming out, potentially reduction in gas, although we don't have numbers for that. We can see some effects here on this thermal image. So I'm just going to put in the last little bit here, go back and forth, so you guys can notice kind of along, especially along this back wall right in here, the area behind this main island, where the lava level is dropping over the last 48 hours or so. So I'll rewind it back, forward, back, forward. You can hopefully see that kind of effect, like it's draining down into a hole. Although that doesn't appear to be enough draining yet for that to be the case. The lava level has dropped about 2 meters. It's about 7 feet since a couple of days ago. So it is dropping down, but one thing we are seeing is, if we look closely, is we see that these smaller black dots, which are smaller pieces of rock that are cooler, floating in a lava lake, that there's more of them being exposed, like they're actually bobbing towards the surface, right? So some of these that were more neutrally buoyant when the lava was a little bit more gassy, perhaps, now are positively buoyant, which means they float if the density of the lava is slightly less, which is the easiest way to accomplish that, is slightly less gas. And when we see that kind of pattern happening in these rocks right in here, and we also see the ledge, actually there's a new ledge forming along this island right in here, then we can kind of say, and actually along over here on this side as well, then we can say, well, maybe it's because the lava density is actually higher because it's lost gas, and that makes everything else kind of float higher in it, right? So not that the islands are all rising up all of a sudden out of nowhere, but more that the lava level is losing gas and kind of shrinking a little bit. And that might account for most of that 2 meters or 7 feet. And we still don't know if there's any possible feeder or anything at the bottom of the crater that could possibly be a drain or something like that, or, you know, other parts, other fissures, the drained north vent, which is underneath the crust over here, right? We kind of saw that there's still lava going a little bit under the crust in these directions. We saw occasional pop-ups on this warm ring in the back, but we're not really seeing that at all recently now. It seems like it's mostly cooling on its backside, but possibly there's there's the original fissure down in here, there's an original lower fissure down in here, besides the actual current active western fissure, which is right in here. So just a couple more times, go back and forth, back, forth, and kind of see that drop off happening there. So we can come back to this if we need to in a little bit. But let's show you guys this view now for the last 4 days only from the S1 camera. That's in the south part of the caldera. So north now in this direction. Before we were looking off in this direction. So we saw the west vent was at the bottom of the frame, now it's on the left. You can kind of see the island is center but facing a different direction right here. And here's the back part of the island we're interested in, where the lava is coming around over here and over here. And that frozen surface on the eastern half is all over here. So you can kind of see there, gas kind of blowing in every direction. It's been some crazy weather around Hawaii in the last few days here, so that's going to continue. We'll show you guys some of that. But just kind of rewind you guys a little bit here, you can kind of see this last nighttime image. Everything is confined to a more shrunk, smaller area that's still active on a surface right below that west vent, which according to geologists continues to supply lava into the lake. So it's not that there's less lava coming in necessarily, but maybe the kind of lava is a little denser. Maybe there is a little less lava. It's hard to tell that as well. But it still hasn't stopped, unlike what we saw the last time, right? So let me rewind here and say that back on January 20th, we had a similar deflation-inflation cycle. In that case, it lasted from about mid of the 19th to turned around, started inflating again 21st. So that was only a couple of days. So the one we have now is actually longer. It's like a one we had before that. But you can kind of see that it dropped in order from 2 to -4, 6 microradians or so. So I'm just going to play this little excerpt of that previous video, so you can kind of see that when that happened the last time, we actually had the western vent almost shut off. We had almost the whole surface become stagnant and undergo that overturning process. We haven't seen that this time. That's one difference. Maybe if the deflation extends longer, we can get to this kind of stage, but so far we haven't seen this kind of stopping and starting as much from the west vent. We've seen little variations recently in videos, but nothing to that extent. And that same view from the S1 southern camera, showing, you kind of see that pulsing of more lava than less lava coming out of that west vent, and kind of the whole surface resurfacing and small flows going over the top. So in comparison, what we have going on now is much more active in this actual western section here. Well, this is to remind me that I want to give a shout out to Bob Martin, who's been collecting all this data for us to make all these fantastic time lapse. So mahalo, Bob. All right, so back to what it looks like now. Rewind us a little bit to the last couple of days here out of the S1 camera. The lava is just on this southern part over here. and not so much, you see some glow, but not so much activity here on this backside. You can also see a little ring, like a little rim forming right in here. We already had these cracks on this eastern side over here, but now it's a more visible rim over here on the north side, and also a couple here on the south side. And if you look closely, there's a little bit right around this island. We have now a lower ledge right in here that's just outboard of that inner higher cliff that's right over there. So similar kind of shape. We can look at that a little more easily when we look at the photographs from USGS released today. So I'll just switch to the USGS time-lapse automatically generated for the last 24 hours of the thermal. You can kind of see it almost looks like in this looping view. It's just like just bubbling on this west side of the island only, and not a whole lot happening beyond that over here. So we'll show you guys the pressure variation first. So this is the raw data from Uekahuna. Microradians, 2 microradian units here on the left. So we are on a time axis on the bottom right, all the way at the right side over here on February the 5th. And you can kind of see we've bottomed out of what was a bigger drop, and now we're kind of on this flatter bottom part. So we expect it to go back up again in that kind of fashion at some point if it holds to the similar pattern of deflation inflation. Here's that other one I just showed you guys that caused that drop in the lava level. This one over here didn't do that. It kind of kept going despite that. And there was an earlier one, it was the first one that we had, it was about a month ago now, that was a much longer drop before it came back up again. It came back up a lot more than it actually dropped, but the drop might have only been in the order of 4 microradians compared to our current one is also about, looks like about 6 or so. But the duration of that one about a month ago was about, well, maybe 3 full days, from right before the 7th to right before the 10th when it turned around. So that kind of timing, right before the 3rd it started dropping. You might think right before the 6th, that would be tonight, maybe it would come back up. If it goes past tonight, then it'll be the longest deflation event we've had thus far beyond the original eruption. And if we kind of recap going back, our biggest drop was that 45 microradian drop at the very beginning of the eruption when the lava first came out of the ground. So we had, this is that next longer one. We have one that's similar to that in length, but a little bit deeper now, happening now, but we haven't got anywhere past this bottom part of it, where we are essentially there. We look on the USGS information site, and kind of see the zoomed in 2-day view right here. It looks like a steady down, but the scale is important. We're only going from -0.6 to +0.8, so that's only 1.4 microradians. If you zoom out, look at the scale of what we've been seeing in the last week, you can see that we're down here at the bottom in this flattish portion, whereas we really dropped most of that 6 microradians already, so that last 1.4 is just a tail end of it, really. That's the blue line we're looking at, the green line being Pu'o'o, which is a couple days behind and displaying, so we'll just ignore it for now. And you can kind of see here in our month-long view, a little bit squished a little more vertically, but that same kind of earlier deflation-inflation pattern. The middle one, which was the same depth, but not as long, and now this one that's both deep and long. So we'll see what comes of this. If we look at the GPS on that same page, you can kind of see, let me zoom in way here on the cross-distance caldera. So this is how wide it is from wall to wall, north to south of Kilauea caldera. And it spreads apart when magma is pressurizing and filling below that, and it drops down when it's relieved through this main first part of eruption. And it's followed that kind of same deflation-inflation trend we've seen, and we speculated that it might do the same thing again and drop down, and here it looks like it is possibly dropping down, and you would imagine it would come back up again. And that's kind of the question is, does it keep up this upward trend, or does that reverse or flatten at some point, or at some point does it actually go back down? That's really the long-term question here we're keeping our eyes on, and as it develops in slow motion. So that is the tilt, and here is a photograph view. This one is released today from the 3rd, so I can kind of zoom in right away here and show you guys this island. You can see pretty clearly there that there's that lower ledge now, like a lava bench, right? We had this original upper black ledge that formed when lava was much gassier at the beginning of the eruption, and it was all the way lapping up to all the way here. And that was mostly when it was out of the north vent still. Since the west vent, it hasn't lapped up nearly that high. It's been mostly at that same level right in there. Right, so for comparison, I'm going to pull up this image that we've showed you guys before from a slightly different angle. We're looking This is north now, so the other image was looking at this side of it. I was just pointing out the rim on this edge over here on the left. Right, you can kind of see, I can zoom into it. It's lapping right up there. This kind of more silvery lava is the active stuff. You actually can see red lava squeezing up right in there. You can see right at that same level as that bottom. You really don't see that bottom ledge exposed right in there. So going back to the third, there it is. You can kind of see it's actually dropping. It's looking to be darker. There's more shadow because the distance over here is increasing. Right, maybe only 2 meters so far, 1.5 or something. I'm not sure exactly how tall that thing is. Less than 2 meters, 2 meters max. But you can kind of see it seems to still be growing as the deflation and pressure drop continues. So that's the zoomed out version there. Kind of looking down, Western Vent putting out all that gas, and most of the features you guys are already oriented with. So I will move on and jump to this one, overflight from February 1st, 4 days ago now. And you can see that similar kind of pattern. You really can see that ledge on the eastern side a lot better, but really we know that that whole thing is frozen in place and lava is really leaking up along the outer edge now, very, very slightly, to the point where this is lifting slowly, but it's not rising as fast as where the lava is actually pooling into this western section over here. All right, so we also have images of the rock debris. We've seen that, talked about that in the last couple updates. So we'll move past that today again and look at the plot of the lava depth. It's automatic, right? So what we have here on the left is meters, and we are now in a range of 200 meters is this line right here, over here. So we're kind of above that at this point, but if I zoom in, you can see this most recent little downward pattern right there, right? Going from a level of right there to right in there to somewhere in there. Not very much, a couple meters, 7 feet, but it's something that makes us think about, and something we want to watch to see if it continues going down, or if at some point it kind of just, at some point if it's only gas, you lose most of your gas and that pattern levels out. Whereas if it's draining for long term, then you should keep going down for longer indefinitely. So that's what to look for there. Okay, so we'll go to the USGS text update page, and our number is actually 211 meters, 692 feet. So it's actually 2 less than before. And new gas number is 2,200 tons per day on February 1st. That's that same data point over here. So we still have that kind of long-term low pattern still, but elevated above background levels, but still below the 2008 to 18 long-term lava lake. So still in some in-between zone there, not quite clear where that's leading us. And we will look first today at the purple air. So there is still VOG coming out, but you don't see a whole lot of numbers a lot of places. You do see one kind of yellow over here in North Kona, but a lot of the other areas aren't the case, despite the fact that if we look at our Mauna Kea VOG forecast here, you kind of see that there's VOG in both to the northeast and to the southwest of the source, Kilauea, right in here. So that's an indication that the winds are swirling or switching back and forth, and it's kind of going all over the place. And that's a pattern of our unstable weather that it's more frequent for us in the winter here. And so it's not just that, you can kind of see there's quite a lot of reds. I even think there's a blue that comes up at some point during this forecast because of the air being so still in some areas and then moving a lot in others. We can actually turn to the radar over here and kind of see that in the last few hours here over eastern Hawaii, we have a couple of red spots of where there's actually some thunder and hail, and we've got a report of a water spout offshore right over here, all in this eastern part of Hawaii Island. So we'll now turn to our user submissions, and today they're going to be a little more weather focused from Hawaii Tracker Facebook, but that's just what's appropriate today. So we will go first to Sarah Wilkinson and play this video of the hail.
Yeah, hail in Pahoa, which is talking to residents that have lived here their whole lives. Nobody remembers hail that I've heard of so far. And at least people are that have lived here that long. Yeah, hail in Pahoa is crazy.
Yeah, it's certainly not a common event for sure. So really, really an unusual
And
event.
the thing about it is too, it's like the hail that they got in Pahoa wasn't just some small little bitty hail. Harry Durgan posted a photo of a piece that he went and grabbed. He, operates out of the new Punakai shopping center.
Mm-hmm.
So he went out there and grabbed one. It was about 3/4 of an inch in diameter.
Wow.
That's a big piece of hail. Like
Yeah.
that's not little tiny.
Yeah, especially for us, because I mean, really, what it is we have usually fairly stable weather because of our isolation and a buffer of the ocean all around us. So that's why it's so rare. Not as common as on the mainland. Just without getting too deep into it.
Right.
And this Dane, we were looking at here.
This one, I believe, is the waterspout. Yeah,
Yeah.
the waterspout, Hawaiian beaches. We had this submitted on Tracker just a little while ago. I've seen some videos of it as well, but it's just, it's pretty crazy. The hail, snow, waterspouts, volcanoes, we get all of it. All the crazy stuff going on today.
Yeah, so this is definitely out over the ocean, yeah?
Oh, yeah, 100%.
Yeah, just to assure anyone who might have residence nearby, it's been confirmed it's out over the ocean and not really threatening any houses, anything like that. So it's more of a curiosity, but still kind of a sign of the weather.
And I've just, we have waterspouts out here pretty commonly, at least a few a year that we see reported, but they're usually off of Maui, the ones I've seen, the most common ones, or off of the west side or the north of the island. But an east side one, I've only seen that a few times out here.
Mm-hmm.
Right, that one's pretty on the rare side too.
Yeah, so fascinating. And then we'll end with one more user submission here from Heidi Fickinger. I'm sorry, Heidi, I totally butchered your name. But Mauna Kea, another frigid but breathtaking day on Mauna Kea. So you can kind of see that part of this includes winter weather in our summits. So in fact, there are some closures because of the winter weather, and you can kind of see some fantastic views as well. Thank you, Heidi, for that submission to Hawaii Tracker. And kind of one last one before we take a quick break here to talk about our sponsors and take some questions. Look at the live webcam view from Mauna Loa, Mokua Ve'oveo crater, northwest rim. We have snow up within. This is Mauna Loa caldera in here, and so we are going to talk about Mauna Loa today. Mauna Loa is coming up next after our little break here, and this will be our kind of teaser transition zone for that. So,
right. So yeah, we are going to do questions at the end today, and we'll get into our new sponsor, which is awesome. We've really been trying to make this a more full-time or at least part-time and sustainable type position that we're doing, or type gig that we're doing. And this sponsorship with Kaleo's Bar and Grill really helps us do that. We'd like to partner with trusted business partners around the island that we can vouch for, they can vouch for us, and we can create this, mutually, this community environment where, they're a part of the community. And Kaleo's Bar and Grill has been, a stand-up part of the community since I can remember them moving in, which has been several years now. I eat there regularly, a great menu, competitive prices, great experience for, I lived here for, 13 years and I still go in there and eat there as a local, but as, plenty of tourists think that's the place too. So yeah, Kaleo's Bar and Grill in Pahoa, that's our new sponsor. And yeah, stop by, say hi. They have the right COVID policies. Outdoor dining is available. In case you're a little sketch about going into, crowded environments, outside dining, perfect.
Yeah.
And great food, great music.
Also takeout is there. So yeah, there's definitely a lot. Yeah, you can kind of see this image on their webpage right here, which is kaleoshawaii.com. This image of when they were around during eruption. You can kind of see the glow of the eruption over here in the background. I'm going to travesty and draw on their webpage right there. But that's the style of how it goes here in the community in Pahoa. So mahalo Kaleos.
Daisy asked if they can deliver to Virginia. I don't think so. My DoorDash that's out of range.
Oh, mahalo. So yeah, mahalo kaleos, and we'll have more exciting news on that front for you guys in the future. So we're gonna see the questions till the end, Dane. Is that what we're gonna do? We'll do Mauna Loa first.
If you'd like, or we can do a question. I have a few now. You can hop in too.
Yeah, if you want to, we're gonna do Mauna Loa, and then we're gonna wrap it up. So if you want to split them up, that's fine.
So we do have some Kilauea questions here. So let's take out those real quick. Have past lava lakes ever overflowed into the caldera and out of the caldera? This one is from Tammy.
Mahalo, Tammy. Yeah, they certainly have split out of the crater at some point. What you have is it just keeps filling until eventually some eruption is gonna spill over, and that's just kind of what it does until it does some other flank eruption and collapse kind of thing. So it's quite common for them to go into the caldera. Out of the caldera is a little less common. The caldera's got to be all the way full for that to occur, so that's less likely. It hasn't happened anytime recently. So, but within the caldera, the last big flows of a lava lake were probably in the 1920s that spilled over and kind of went into the caldera floor. And yeah, there was quite a lot. 1919 covers most of the north part of the caldera floor still today.
And the overflows that we saw from the Halemaumau prior to the 2018 eruption, those just are right below what would be considered the caldera floor.
Yes, I mean I would call. I mean that. So that was we had the overlook crater that had the lava lake, and it spilled over into Halemaumau crater. But then Halemaumau crater is within the caldera. And so it kind of depends how you draw those lines of where is it spilling over. And so it kind of spilled over into that, came up that narrowest conduit, spilled over, but then it still had another big crater to fill before it could spill over into the caldera. And the reason that is that big crater was formed in 1924 from the explosion, so that's why it's such a big crater. And that's more work to refill all that kind of thing. So in the 1920s, it was a much smaller opening and much deeper, and so the lava would come all the way up and spill over and go a lot farther away. So it might have to build up that way over a long period of time.
Right. So as to the next question is from Daisy on YouTube. As to the lava lake, where is the lava going? Is it giving the appearance of sinking because of some deflation at the summit, or is it actually draining back?
So it could possibly be draining. We just don't know. But there is an expected loss of gas that happens continuously, and the lava will kind of shrink in volume because of that. Shrink in volume, but increase in density, and that's why we're looking at those little islands as some possible clue, giving us some kind of clue at the density changes. And it does seem like the lava is a little denser because all those little islands over here, they're appearing kind of coming out of the lake. You can't see it as easily in this 24-hour time lapse, but maybe if I can pull back the other one, which is over here, and you can kind of see if there's a frame like this, you only have 3 islands visible. 1, 2, 3 sticking out. And as we advance, you can see more and more and more of them emerging here at the end. As you see, 1, 2, 3, 4, 5, 6, 7, 8, and then a bunch more over here on this side. So that's why I believe that the lava density is actually increasing. You see all these other rocks that they probably haven't changed density. It's a lot harder for them to change density if they're encased in lava, right? Than the lava itself that can lose gas, which we see the thing degassing and losing heat continually.
All right, we have a question from Facebook from Claire. What are the chances of it really going, big time on an eruption at this point?
Well, that seems more likely if you see some kind of new batch of magma coming up and in, and kind of something out of the ordinary. What we're seeing is an ordinary progression of buildup over time and then a release of that pressure. So we have already seen from the geologists the report that initial lava that came out was stored in a summit for some time, which means it's probably that same lava that's been feeding a 2008 to 18 lava lake that fed the eruption in 2018 in Lower Puna. Still that same stuff. So it's not new stuff that's come out of nowhere and it's going to suddenly create a much bigger, different kind of eruption. It's just more pressure of more of the same. And so that seems to make it less likely it's going to just go gangbusters out of the blue, right? But that that could happen if another batch of magma does arrive from below at some point in time. So we're not seeing the signs at this point. It's kind of possible. It's a volcano. It does what it does. The signs we see from this eruption are not that at this point. Mahalo for the question.
Yes.
So
as to the lava lake level.
Mm-hmm.
Oh, sorry.
Oh, go ahead. You got another question? Go ahead.
As to the lava lake level. Yeah. As to the lava lake level, has it been increasing or decreasing over the past week, and how much? Is a question from Chuck.
So it's in the last 2 days. It's lost 2 meters, 7 feet. The 2 days before that, it hadn't changed. And the 2 days before that, it might have gained 2 meters. So it's probably a net even over the week. Yeah, but that's how it's changed. It kind of went up a little bit, stabilized, and now it's gone down.
Question from Keith is: do you think that the rubble plug from that was the bottom of the collapse pit is further compacting?
I don't know that that's compacting any more than it did. Because it compacted originally from all those earthquakes at the summit 2018, 60,000 earthquakes at least, depending on how you measure them. In comparison, the lava lake is filling more gradually and more slowly, so I don't really see it doing that kind of tamping down action you would expect. That the earthquakes really did do that. So I think it's probably pretty well tamped down, and I don't think there's that much change at this point, to be honest. But just my personal hunch, we're not looking at it, we don't know.
Right, we have some good questions coming in. Victoria asks, deflation seems to be happening at a longer interval than the inflation that we're used to, probably with the DIs. Could this be the beginning of an end to the eruption?
It could be. Certainly, one thing we've seen at Pu'o'o is if deflations last long enough, then it can actually impact the dynamics of the vent. So the vent can get plugged or clogged, and it might force its way out somewhere else, or sometimes it might even start a pause, before it can build enough pressure to start again. So that kind of thing is possible, and it all depends how long it actually stays deflated. And that depends on what's causing it, which we honestly don't really know. But the mechanism, more or less, is thought to be you have some, you've built up enough gas-poor magma that's denser that it essentially, even within the conduit, it's going to try to go back down. And then the fresh hot stuff's got to step out of the hallway because only one can go through at a time. So it kind of steps to the side, lets through the denser stuff going down before it can go and take its turn to come back up. Right, so that's more or less what's happening. It's like some pathway where it's too narrow for them to both go by each other all the time. You have built up enough stuff, maybe in a shallow stuff that wants to drain back down. It kind of forces its way back down. The whole volcano deflates, and then at some point that slug moves out of the way, and then it gets replaced by the hotter, fresher stuff with more gas, and then usually it comes back up quickly, right? And then it kind of levels off when it refills that area and re-equilibrates. That's what we usually see, and that's what we can expect to see until we don't see it. So, how long it lasts, it shouldn't last that much longer. I don't see the actual mechanism for it being that much different than the last few that have happened. So I'd be surprised if it goes on for a huge amount of time, but it could. We're just kind of trying to give you guys the best ways to think about it without really knowing the answers. Kind of speculating in a process to kind of help educate in that way, rather than like say for sure it's going to be this is what's going to happen. So
Bugsy Boy on YouTube asks, is this new lava or lava left over from 2018?
Well, it's lava from 2018 is what began the eruption. That was the first sample as reported on. We haven't seen any report on how it's progressed since then. But likely it's one big magma body. The lava lake from 2008 to 18, its signature is of the lava that was able to degas in the lava lake and go back and mix back in. So it's had some time and it's lost some gas. It's sat around for a while. And so that kind of signature, I think, is what we've seen reported on continuously, even as far as the CO2 to SO2 ratio from the gas scientists. Right. So it seems like it actually is. It's like there is hotter stuff below that, but it's still like pushing in line. It didn't cut to the front of the line to get ahead of what was here already. It's just kind of still at the back of the line, and what's at the front of the line is the 2018 stuff still.
So we have one more here that is a little more big scale, a little more general. Is there any correlation between this volcano activity on Kilauea and the volcanic activity and seismic activity happening around the world right now? I assume that would relate to Ring of Fire and that kind of talk.
Yeah, I haven't seen anything specific recently. It's something where, you know, big earthquakes they are felt and measured in all the instruments in Hawaii as well. And if the volcano is, you know, at that point where any little thing could cause it to blow, then that might be the thing that actually does it, right? You could have situations where you might have even an eruption that's over. Let's say this eruption right now lava were to stop coming out, it crests all the way over, that there still has a gooey center. Then we have a big earthquake. Well, that earthquake could actually shake up that lava body inside of there and cause a small eruption. That happened in 1975 in that very same pit. In 1974, Lava Lake was crusted over. We had a big earthquake, 7.5, 7.7 by some measures. One-day eruption by shaking up, right? It's almost like having that bottle of soda or champagne, and you give it one last little shake at the very end, you can cause a little bit more gas to come out. One last little burp, so to speak.
Right.
So that can happen. But that's a rare thing. Normally, there is no connection between what's happening. It's kind of an independent system, even between Kilauea and Mauna Loa, two volcanoes on Hawaii Island, much less Kilauea and any other volcano anywhere else in the world, right? So, but earthquake energy does travel around the world. That's measured and affected everywhere. The magma systems are all separate, really, when it comes down to it. And there could be changes in the long term, but the Earth, the mantle, is moving at the rate of inches per year, and so those changes are not fast changes that the Earth feels and says, okay, well, in 1 minute, this is what's going on in Chile, we're going to put that over here and affect Japan. It can affect things, but on an order of, well, how far is it, and how many inches is that, and how many years does that mean it's going to be, what's the scale of the change? And usually you end up with millions of years for these things to actually affect each other on a scale. Is that what people imagine them happening, it does do that on a geologic time scale, but on a human time scale, not so much.
Right. We have one last question, and it kind of plays into what you're just talking about. Maybe you can just expand a little bit. But None Your Biz asked on YouTube, why is there a lava pipe going under Hawaii to the center of the Earth? Like, why is there a conduit? Why is it a hot spot?
I mean, I have an answer, but it's going to be hard with how lining up all my pictures and to do it kind of quickly. But you know, maybe this will be a teaser for some future segment. You know, the short answer is that the interior of the Earth is not all the same kind of goop. There is spots where old ocean crusts have subducted, have basically gone back down the conveyor belt into the Earth, and we used to think that those actually would melt. And it turns out that they stay insulated, much like we see these islands in a lava lake. The thing doesn't actually melt all the way. It kind of stays insulated. It gets more dense, and it sinks all the way until it hits not quite the center of the Earth, but the core of the Earth. I mean, the core of the Earth is much denser than the mantle, so it doesn't penetrate there. It's like trying to go through a wall. It stops there, and it actually piles up in certain areas. And when you have different kinds of, mantle material and different old continental traces from the sediment that washes on the ocean floors and the ocean floors themselves, then that creates the goop that you need to start having heat flow deep down to start hotspots. Maybe I'll just leave it at that, because it's basically, it turns out that, on an order of hundreds of million years ago, under where we are right now in Hawaii, is where a lot of these old fossil ocean tectonic slabs hit the core of the Earth. So maybe it's...
And when you come up, goes into another question, is the classification of them being different volcanoes, right? They're coming from the same source, but they're classified as different volcanoes. Why is that, real quick?
It's about how we see the magma bodies being connected or not. And so we can tell the magmas have unique chemistries. Every magma's got a unique chemistry that's like a fingerprint. I could tell magma from Mauna Loa apart from a magma from Kilauea very distinctly. And all the ones in Mauna Loa are the same, and all the ones in Kilauea are the same. So then we can say, okay, well, those are two separate circulatory systems per se, right, of the volcanoes where the magma is flowing through. The opposite example is, for example, Halemaumau and Pu'o'o, right? Those two different vents on the same volcano share the same magma, share the same circulation, or the same volcano. The volcano is called Kilauea, right? And Kilauea is host to Halemaumau and also to Pu'u and also to East Rift and Leilani. And it's all the same volcano, even if it's different points in the ground, 30 miles apart, where lava comes out. So it's all about the chemistry and the connectedness underground.
Right. Subsets. There's subsets. Yeah. Some of them. All right. Well, that does it for me on the questions. We will be doing one more question and answer round at the end. Back to you, Phil, with a Mauna Loa update.
All right. Sounds good. So we will start off by showing you guys this Mauna Loa webcams page, which, if you're not familiar, is a good place to come and look at what's going on. And so if you want something a little bit more visual than we typically have in Mauna Loa, there's you guys a summit snow already. There's actually a thermal camera up there. Very important to look at the scale. The uppermost reds here are 15-20 degrees Celsius. So we're not dealing with the same. This is not lava anywhere over here. All right, so there's a camera here on the south rim, kind of foggy. The south pit, you can kind of see the sun's going down. Northeast rift from Kilauea. This is a more cinematic one here, the southwest rift zone. Middle part, you see all these cinder cones, lava flows around them. A little bit of snow up on a mountain up here in the top right. Flank of Mauna Loa. And another one here farther down, the southwest rift. All quiet, not even any gas coming out anywhere. That's just what Mauna Loa looks like now. She's still swelling inside, but still at fairly low rates, right? Here's the update this week from Mauna Loa. And it is short and sweet, not erupting, not changed significantly over the past week and above long-term background levels. During the past week, 95 small magnitude earthquakes. So 95 per week is very small, below the threshold. Look at the plots here. That 95 comes in over here to the right, this little bar graph over here. This is the last year. So we've come up to almost 200 in 1 week. But if you guys want to go review Frank Truesdell's information on earthquakes in Mauna Loa, he was saying that you're looking at in a range of 50 to 250 per day at least that are greater than 1.6. And there might be 5 times that many if you look at all the earthquakes, right? So really you're looking at 250 to 500 per day is kind of the target we're going for when we're looking at these raw graphs that don't have a 1.6 cutoff. So we're nowhere near that at just less than 100 per week, right? So that's one of the important things. Even if she's slowly building, she's not anywhere near close to cracking, which is what really matters. We look at the GPS. This is the cross caldera distance at the summit, so how far apart the caldera walls are getting back and forth. And you can kind of see that we discussed last week this little variation down here, and we talked about how we had information from GPS on Mauna Loa from USGS that perhaps this is because something was happening north of this one station, and now it seems like it's resumed its regular path, and it's actually climbing fairly steeply, nothing alarming yet, but it is kind of recovering and readjusting to that. So like I said, by itself, it's just okay, it's certainly still filling, but the earthquakes are kind of one of our more important milestones there, right? So we'll look at the earthquakes here. You can kind of see that this is we're looking at a map, and there's only a few that are orange. There's persistently some in Mauna Loa, but not that many and not in great numbers. So we know magma is moving through there. We know it's probably filling more passively. It's not actively working towards cracking the ground towards an eruption. Okay, so our Pahala zone is still very, very active. Lots of earthquakes there. Most of the earthquakes every day are happening down here in this zone, and we still have some kind of south flank activity over here. Is still the results from last week. There's one more we see here coming in today at 2.6, kind of related aftershock-ish to that 4.1. So that's it. And these are all, if we kind of zoom in, we can kind of see these are all south of the East Rift Zone, which is right here. So this is all south flank, and the south flank moving or not moving, perhaps starting to stick a little bit more in some of the areas with the adjustment of all the magma causing eruption here at Kilauea Summit. All right, and then one last thing. Speaking of the south flank, this week's Volcano Watch is on Kilauea South Flank, kind of a follow-up, putting that 4.1 into context, talking about how everything is still adjusting after the 6.9 in 2018, May 4th, 2018. And if there are questions, we can get into this a little bit more, but I'm not going to otherwise dive into it too much. You can kind of see that magma filling the rift zone is what pushes the south flank, and it causes earthquakes along the faults. And this is a very simplistically drawn, a very flat line here as the fault. Whereas we've shown you guys more accurate data that actually shows how these things actually have bends in them and other structure as well. So it's a good article. You guys should go check it out. There is nothing really urgent in here to discuss that we haven't discussed already, especially considering our addressing the whole helium slump last week, right? That's kind of what this is following up on as well, as this whole helium slump concept and how the south flank moves in result to changing magma pressure. So it also mentions, how unique it is to have seen the rift zone draining back into the summit, and how that pattern actually manifested in 2018. Or since 2018, yeah. Since build up since 2018, and then kind of draining back in 2020, 21. All right, so and then we have updates at the bottom, and that is what there is for the Volcano Watch. So we can come back to this if there is interest. Otherwise, hit us up, Dane.
Yes. We have a few questions actually about Pahala that have come in, and the earthquake activity there. And does that mean anything? And does it suggest anything could happen?
Not really. So we've kind of addressed this before. It's almost a background to us at this point. It's a background activity. It's not anything we can really link to any surface activity, especially in a short term. Maybe there's some longer term implications. Maybe this means that there's still flow from the hotspot to Kilauea, right? Because we know there's flow out of Kilauea up here. Maybe it's still flowing that way. We know there's flow to Mauna Loa because Mauna Loa is still filling. So maybe there's some magma still flowing to Mauna Loa. Maybe it's as simple as that. It's still moving in there, and it's going to where it can go to fill, but it can fill passively, and that by itself doesn't mean there's going to be an eruption. And so it just means that we're alive and well, magmatically over here.
So we have a question about Kilauea, like so outside of Mauna Loa and Kilauea, that's where we normally focus on. From YouTube, the question is how many other volcanoes on the same island could erupt? But let's say in our lifetimes.
Well, the easiest, so all these questions are part of a presentation that I actually have that I'll have, maybe next week we'll share with you guys.
Do that. Right.
But Kilauea is erupting now, obviously. Mauna Loa's last eruption was 1984. So a geologist describes a volcano as active if it's erupted in the last 10,000 years. And that's kind of an arbitrary number, but that's more or less what we've settled on as long enough to wait for a volcano to not erupt to move past the active phase, right? And that just that concept can be a little bit hard to understand. And the way I relate it is, if I'm going to do first aid on somebody, like if I come across someone who's not breathing, and I want to assess if they're breathing or not, then normally I have to watch for a breath, probably at least for a second, right? If I show up and I wait a quarter of a second and say, "Look, he's not breathing, she's not breathing," and move on from there, well, I haven't realized that a person maybe breathes once every second, and I haven't waited for long enough for the breath to actually come. Right, so that's what makes like a 1 second more or less a reasonable time to like listen for is the person still alive? Let's listen for 1 second. Right, so is a volcano still alive? That time is 10,000 years. Well, that's the definition of active. So 84 is within 10,000 years. That's active and dormant. Kilauea is active and erupting. Right? Loihi's last eruption, we believe, was 1996 offshore. Active and dormant. Waialae over here. Its last eruption was 1801. Active and dormant. Mauna Kea, about 4,500, 5,000 years ago, less than 10,000. Active and dormant. Kohala, that gets to the hundreds of thousands of years. That one's one we might actually call extinct. Extinct doesn't mean it won't ever erupt again, because there's volcanoes on Maui that have gone into that later phase, and then it can go into a rejuvenation phase, for which I won't get lost in the weeds there. But these volcanoes can have later different kinds of eruptions, a lot less frequently. But you can kind of go over to Maui, and you can zoom into Maui, and you can see there's Haleakala caldera right in there. It's got a flat bottom, like it filled with lava, and it has a big valley over here on the south side. This is the Kaupo Gap, where you can see lava has flowed out of the crater through an old valley that wore into the side of the volcano. So Kohela's got big valleys like this. It's possible that you could actually have something, induced where you shave off enough of the top of the mountain, and if there's anything still liquid inside anywhere, it might ooze out. Right? It kind of depends on what's happening underground also, as far as melting and all that, and that's a much bigger topic than this. I'm just going to give you guys a couple of examples. So, Haleakala, 1790, active and dormant as well. Right, so that's the range of ones that are fair game in our lifetime.
All right. Plays into that question really well. Craig asked from YouTube, I heard that there is a similarity between the lavas of Kohala, Mauna Kea, Kilauea, and the lavas of Haleakala, Hualalai, Mauna Loa, and Loihi. Not the same, but closer.
Yeah,
so
that's
maybe
true.
The differences on them.
Yeah, so this is also something that it's got to do with the chemistry of the lavas of the volcano. And essentially what he's talking about is there are two trends, two kind of chemical trends. One we call the Kea trend, where these volcanoes line up in composition, and then the other one is the Loa trend, where these volcanoes line up in composition. And that's a bigger topic than when we do that presentation next week, perhaps on that whole geologic context and background. It sounds like everyone's ready for that. Then we can go into that a little bit as well. But that is true. And that's something that's only occurred. You don't really see it back past Oahu. So that's kind of a new thing. So what might that mean? Right? Why does it suddenly appear? Right? Why is the trend of these upper islands more that way, and the trend of these islands is more this way? Why did that angle change? What the heck's going on here, right? So there's all kinds of geologic questions. You follow the hotspot back further in time. This whole Emperor Seamount chain, Hawaiian Emperor Seamount chain, has got a big bend in it as well. You can trace it all the way back to the Aleutians over here. Almost at Kamchatka, right? There's Kamchatka. Here's part of that same hotspot from close to 100 million years ago. That's still persistent on the ocean floor.
So we have a question from YouTube. Zoom tight. How does volcanic activity and earthquake activity follow the pattern of El Nino?
I'm not quite as familiar with any relationships there.
Yeah, I can't say I've heard of it.
So I don't know that I can really answer anything about that. I don't know any connection between the temperatures of the ocean as much and interaction with faults or volcanoes or that kind of thing. What I can say is, you do see there can be changes in long-term weather when you look at things like how much ice is there on the surface of the planet, and how much water is in the oceans in total. Because the oceans do put some weight on the crust of the Earth, and if you have a global ice age, for example, and you have a lot more water not in the ocean but on land on a glacier, then that can change things both on the ocean and on land, right? But it usually takes a kind of extreme variation like that rather than what we consider a normal El Nino year-to-year pattern that we've seen in our lives, all of us.
Different time scales.
Yeah.
Oh, I had a good question here. Here it is. So back to Mauna Loa. Are summit eruptions or flank eruptions more frequent? This is a question from Robert.
So on Mauna Loa, summit eruptions are more frequent because almost every flank eruption is preceded by a summit eruption, and not every summit eruption leads to a flank eruption. I don't know if that makes if that makes sense. I said it too fast, right? Like if you have a flank eruption, you always have a summit eruption beforehand. It may not be very long, but it might be long. Whereas sometimes you have summit eruptions, and then you have another summit eruption, another summit eruption, and you don't go to the flank. So summit eruptions are more common, and that's true mostly at most volcanoes, right? If you think about where this leaky tube of toothpaste is oozing out, the spot where it oozes out and piles up the highest is where it comes out the easiest. So the highest point of the volcano is the most likely to erupt in the caldera.
Summit flank sequence. Has the hotspot material flow rate changed in geologic timescales? And how do we estimate that? Does magma supply from depth oscillate at lower frequencies? And we're just like, what's the timescales on that?
Yes, and without, we'll have to go back to more detail. You guys are asking all the questions of that presentation. I could just pull it up, but then it's going to make us go another.
Yeah, that might be a standalone.
Longer. So it might be a video next time. But kind of at a glance here, you can kind of see that by the amount of landmass on a seafloor, there are times when you have big amounts of landmass, and then times when you have not as many. Right? You can kind of go back in time up the Hawaiian chain. You can kind of see, well, really not a whole lot. I mean, maybe this was a big one right here. Right? A lot of built up seafloor, and then over here you get not a whole lot, almost nothing. Right here, right before this bend, almost nothing. So certainly there are long terms, and this is millions of years. This bend is about, I want to say 43 million years ago. So 43, and you might be back at 30 million. I'm not sure exactly where the 30 line is, but you get to 6, then you get to 1 over here, and that's the range of it. Whereas over here we're at close to 90-ish, kind of depending on the accuracy of the dating. So certainly, yes, you can kind of see, just looking at the seafloor, there's more material in some parts, and then less in other parts, and then more, and then less. So yeah, that's one way.
All right. Well, I think that. Oh, we have one more here. Andrew asks about the sulfur emissions. Mm-hmm. Where does all the sulfur accumulate, and where does it originate? Like, where does it go? Where does it come from?
Well, so it actually comes from is easier. It comes dissolved from the magma at depth. I mean, it's just part of the magma soup that's down there, and it's something it's in solution until it gets shallow. So it's not like it's like a gas moving around the magma at any time other than right before we see it come out of the ground. So normally when it's down there, it's just part of the soup, kind of dissolved in it, right? And so that's where it comes from. Where it goes is a good question, right? I suppose the best thing we could do is pull out these global SO2 maps, but imagine a lot of it probably falls in the ocean. Some probably falls on land. The VOG, you can actually have particles falling downwind, but they probably blow all over the world, and the small stuff falls probably anywhere, right? When you study geology, you quickly learn that the most common signature you find of anything, of any kind of dust, is from the Gobi Desert, because the Gobi Desert sand just blows all over the whole world. So you can, I would imagine that you might have traces of this a lot of different places. I don't know exactly where, depending, maybe the wind doesn't blow so much to Argentina or something, but
we get in the predominant, wind streams and kind of carry with the wind patterns. Yeah, that'd be my estimation.
Yeah, but so yeah, it kind of spread out, and you might have very, very, very small amounts all over the place. Kind of disperses, really, right?
All right. Well, we do have some donations I want to shout out. We, with 3 real ways that you can support Hawaii Tracker. First way as a user is to like and subscribe to this channel, like this video, maybe consider sharing it. We don't have the advertising revenue of a lot of big organizations, so we rely on word of mouth, and just, that little bit helps us a lot. Second way is to become a user on hawaiitracker.com. It's a community-based social media site trying to do something a little different with less dumpster fires and more people trying to help each other. And then the third way is through monetary support, hawaiitracker.com/donations. You can contribute directly to making this project continue. And with that, we have Andrew P., Susie C., Erica S., Peter H., CCB, Mark D., Melinda H., and Janet L. So yeah, appreciate every one of you.
Yeah, thank you so
especially
much,
the
guys.
monthly donations. That really helps. We have a $10 super chat from Jeff Williams on YouTube as well. Appreciate it. No message with that one.
Mahalo, Jeff. Mahalo, everybody. And there's one more way you guys can support us. Go check out Kaleos. Right? Tell him we sent you.
Yep.
Yes. Mahalo, everyone. We will be back with you guys after the weekend, and we'll review what's happened over the weekend and dive into more of the monitoring signals. Maybe next week, Wednesday, we'll do a little bit more of this tectonic geologic context you guys are all dying to know so much about. And then we'll wrap it up depending on what the eruption is doing there at the end of the week once again. So thanks for joining us. Go check out HawaiiTracker.com. For Dan DuPont, I'm Philip Ong. Aloha.